Should be good to go.
Yeah, looking forward to this.
Awesome. Welcome, friends. Welcome, everyone. This is Deep Learning Adventures, a fun, engaging meetup with friends and colleagues all around the world. I'm joined today by my great friends and colleagues, David and Robert. And Robert will be guiding today's session on a fun pedal to the metal session with a bike sharing project that he worked in the past. Should be fun, exciting. Let me just share my screen real quick in case you're joining us from Slack, YouTube, Kaggle, or anywhere online. You can find us on Meetup under Deep Learning Adventures. This is the event for today. Robert's going to guide for us. We record all our sessions, including this one, and I'll share the link pretty soon here on the chat. As you see, we've been pretty busy with some basic data science, micro challenges or micro courses from Kaggle, some introduction to machine learning, some introduction to AI, including computer vision, natural language processing. We did a fun one with detecting flowers and cassava leaf diseases with Neil. We did a fun one with Dimitri and Alexander on reinforcement learning and game AI. Had a fun session with the Kaggle team with Dan, Rachel, and Ryan. The last one we did was recognizing flowers with TensorFlow Lite on Android. If you haven't checked it out, check it out. It was a fun session. Today we're going to talk about pedals to the metal. So I'll stop sharing. I'll hand it over to Robert, our great friend, and I'll post some links in the chat for us. Let me enable sharing, and the floor is yours, Robert.
Awesome. Can you all see my screen?
Yes, beautiful notebook.
Something like that. So a while back, maybe over the winter at some point, I was chatting with George about possible events that we could do. And at some point, the topic of past projects came up. And I thought, it'd be fun to revisit an analysis that I had done on Bikeshare when I was actually a grad student at George Mason. Used this basic data set for a couple different projects back then. And when I revisited it this year, realized that, to no surprise, not only has the data set evolved quite a bit, but also my approach to these types of problems and coding has definitely evolved quite a bit. I believe the first time I tackled this project, I was brand new to Python, and so it's kind of embarrassing to go back over my old code. But so I thought that was a good enough excuse to revisit it and see how things could change this time. So to be clear, this is still a project very much in progress. I'm excited to share it with this audience in particular, not only because I think that going deep into the weeds on a project like this can be helpful for many of us to see how to approach problems, but I'm also very hopeful that this audience will have many suggestions and ideas for future developments, either suggestions about things that they would do differently, what they see right now, or ways to develop this thing going forward. As you'll see, the majority of what we're going to talk about tonight is kind of the preparation part. I have run through a number of models, but very much in the initial stages on that. So just that's my initial spiel to start. Please feel free to ask questions at any point. I want this to be a discussion going every which way. So, all right. So let's get started. So the data set that we'll be talking about is, and I have no slides. I'll just be sharing a variety of screens here to introduce the topic. Bicycle sharing system in particular. Let me see if I can move that down a little bit so that Zoom's upper window doesn't prevent me from switching tabs. All right, so bicycle sharing systems are a new method of urban transportation, new in the sense that it really exploded within probably between about 5 and 10 years ago. It came on the scene in many major cities across the world. It serves a niche which had previously not really existed in the urban transportation framework. You had people that were driving cars, and that can be anybody who's attempted to do that during rush hour in a major city knows all of the possible downsides of that. And you had the option of metro trains, subways, buses. Every one of those things has its upsides and downsides. Bikeshare fit a bit of a niche in the sense that it was available on demand for people that did not need to have their own wheels in a particular location. It is spread out across a wide number of locations, so serves far more areas of the city than a heavy rail underground system could serve anywhere. Even in New York, the number of city bike stations greatly outnumbers the number of subway stations, and it's also another advantage that it has over trains is that it's very much available on demand. You show up and you just take a bike. You don't have to wait for your ride to show up. The disadvantage, however, is that it doesn't necessarily scale all that well once a lot of people start to use it. In particular, we'll see a couple of visualizations. This is maybe a special case because I actually took this I think it was the day of the inauguration. Here, let me make that full screen. So all the grayed out stations in the DC area were off limits at this point. The green stations here had bicycles on them. The yellowish had a very small number of bicycles available, and the red ones were empty. And you could see that not only were these stations closed because of all the security infrastructure around the National Mall, but you also had a number of stations that were out of bikes in that vicinity. This general phenomenon is very common in non-pandemic times downtown in evening rush hour. What I found a little bit interesting is that you look at tonight, you can look at the real-time data, and there's very few outages. This isn't the highest quality visualization here because it's difficult to really distinguish from one green to another. Green is anything that has more than 2 bikes, I think. But this really goes to show how things have changed in DC during the pandemic, I would say. Even with the winter weather, it's cold this evening, but it hasn't started precipitating yet. I think that's not supposed to start until, 11 o'clock or something?
Yeah. Is this live, Robert?
This is live. Yeah, this is Capital Bikeshare's live feed map of the
What
city.
is the legend? What is the dark and
Black
what
one?
is the green blue?
So the black ones are actually not docks. They are undocked electric bikes, which are a new thing that started within the last year. That I say that, and it's not technically true because they had started having some electric bikes in the system, I think 2 years ago.
Mm-hmm.
Then they disabled them all and removed them at some point for a safety concern. I think there were some issues with the braking systems. But at that point, all of the electric bikes required docking to return them. at one of these locations here. So you could click on this and it says 19th and E Street Northwest. There's a station there. And presently there are 9 bikes on the station and 2 empty docks. So these random e-bikes here and there are a new feature of the system. They're maybe more useful when you go further out and you get to places that are a little bit farther from the urban center. They expand the reach of the system, at least for individual customers, to places that they might not have chosen bike share as their mode of transportation. You'll note that there's also some competition in the last few years. The electric scooters burst on the scene and really dug into quite a bit of Bikeshare's market share. And I haven't, I think I did play with the data set for that briefly, but I don't have any of that data to share here. One thing that I thought was really interesting about that was that within 1 year, I believe, scooter rides outpaced the total number of bike share rides in Arlington County. I don't know about the District of Columbia, but I did go to a public meeting in Arlington where they showed some data and discussed this, and I was surprised at how quickly that had happened. I guess some people don't want to pedal.
I don't think it's just that. I think it's also that with the scooters, you could leave them anywhere, right? So you didn't have to go to a dock, and I think that made a big difference.
Yeah, that's correct. They, in fact, part of the reason that dockless bikes became a thing was in response to that scooter model. In order to compete with the scooters, they wanted to enable that type of usage as well. So presently, as far as I'm aware, there are 2 types of bikes in the system, and I'll get into this more when we actually dive into the data, but there are these electric bikes which do not have to be docked at a station, and the classic bikes which do have to be docked at a station. The classic bikes are cheaper to rent than the electric bikes. The electric bikes, I believe, I've actually not rented an electric bike, so I don't know what the pricing structure is for that. But I do know that you pay every single time that you take one off the hook. Whereas for the classic bikes, anytime a regular member checks one out of the system, you get your 30 minutes for free before you start paying fees to keep the bike longer than 30 minutes. So with a regular membership, which I've had for probably 6 years in this system, pretty much as soon as the first year that when I moved into Arlington, I think is the year that I got a bike share membership. And I think it was about $50 a year at that point. Now it's up to about $90. But for someone who's using it to go to hundreds of destinations in 1 year, it's a pretty good deal. Mm-hmm. The pandemic, of course, has changed everyone's travel patterns, changed the need for commuting, changed a lot of the downsides of driving. So I think there's been mode shifts all around. But that's the system as it is right now. Interestingly, the bike share system is still expanding quite a bit. There's a cluster of stations in the Reston area, docks out there mostly they're in urbanized parts of the DC area. Tyson's has a number of them. Falls Church and Dunloring recently got some. And also when you go over to the Maryland side, they've been slowly expanding out. These ones up here have actually been there a while. I think Fairland and White Oak are somewhat new. National Harbor is somewhat new. These ones out here in Prince George's, Largo area are somewhat new. One interesting note is that College Park before Bikeshare had even expanded to Hyattsville, before Capital Bikeshare had expanded to Hyattsville, College Park decided to strike a deal with a competing vendor. So they are still not part of the Capital Bikeshare system. I'm not sure what the politics or current status of that is. The vast majority of my use of the system has been in Central Arlington and Central DC. So
what is the legend for orange and red, if you don't mind? Is that availability of bikes?
orange and red are, yeah, it's the color code for availability of bikes. And I guess it's not shown here.
So you have some reds and some
Go
orange.
to an orange one, there's only one bike on the dock. If you go to a red one, it's empty.
Yeah. Okay.
So they've gone through a number of different visualizations here. I will say that some of the past iterations of this were a little bit easier to interpret. It's not too difficult to see where the red ones are, where you can't find a bike. What is difficult to see is where are the docks full, where you can't park a bike. Because that is a potential problem, inconvenience for customers as well.
And one clarification question, Robert. These are all brick and mortar, like these are all docking stations that we're looking at the pins, or are you
All
also
the pins
tracking?
except for the black ones are all docking stations.
Got it. Got it.
So those are stations that are somewhat like, I don't know that I have any up right now.
And the Wikipedia had a picture.
The Wikipedia had a picture.
Yeah.
The Capital Bikeshare stations are somewhat distinctive. I think there was a photo back on our meetup page. Yeah. Here's the actual Capital Bikeshare DC ones, and this is, I think, the station in Roslyn. And that is actually me taking a bike 2 or 3 years ago there.
You look ready for action.
A very nerdy scavenger hunt ride, I believe.
I love it.
If you get a flat tire, what do you do?
Excuse me?
If you get a flat tire, what do you do?
So there are a number of service instructions here. This is Capital Bikeshare's official website, how it works, pricing, find a bike, explore. Somewhere down here is some frequently asked questions, and you'll see answers to that. Essentially, there's phone numbers that you can call. You can, a couple times I've gone to a dock, found a bike that I thought was unsafe for some reason or another, and you can punch a little button that basically locks it in place and notifies maintenance.
No, I mean, if you get a flat tire on the road, you cannot ditch the bike. You have to put it back to a dock, right? So you have to push it. So I'm just curious because I ride a bike a lot. My own bike I have because I'm off College Park and I don't have yet. But I'm very interested, and I have some practical considerations because if I get a flat tire, it's I'm somewhere far from home. It's a long way home.
So I can say, as someone who has taken probably between 1,500 and 2,000 rides in the Capital Bikeshare system. Now I usually do check the bike for a few seconds before I take off. And I think I did mark a couple with flat tires. I've never actually gotten one on the fly. One thing you may notice if you take a look at these photos is these bikes are absolute tanks. They are extremely heavy to the fact that, in spite of the fact that they are supposed to be friendly to be shared for the entire adult population, I have actually known some petite adults who felt they were not strong enough to climb hills in these things because they are heavy, probably 50 pounds.
Yeah, those are beefy frames.
What was that?
Those are beefy frames there.
They're beefy frames. They have 3 speeds. You can't really see the shifter. They're on the right handlebar. The 3 speeds are slow, slower, and slowest.
The tires, are they heavy duty or are they airless?
No, they're air filled.
You can see the valve.
Was that?
You can see the valves of the tires in pictures. I mean, they're
If you squint, yeah.
Yeah. They
So-
are they are beastly, and that is by design because the operators of bike share systems have to assume that you're going to get a lot of novice riders, people who may be tourists just visiting the city for a few days. It's actually a great way to explore a new town. In fact, my introduction to bike sharing systems in general was in 2013. I took a week and a half vacation in Stockholm, and that's how we got around for several days there with their bike sharing system. This is before I had tried the DC ones at all, and it was a lot of fun. But again, those were extremely heavy bikes, and it's for safety reasons. They're far less likely to topple. You're far less likely to get thrown off if you hit a road surface hazard, and you're far less likely to be going at fast enough speeds where hitting these kinds of hazards will be problematic. I can say they do encourage riding with a helmet, although it is not the law for adults in any of the DC area jurisdictions. I can say that while I will always wear a helmet while riding my road bike with skinny tires, many times I would take a Capital Bike Share bike without a helmet. If you're one of the purposes of the system, of course, is to be able to serve people with random trips in the middle of the day. Maybe they weren't planning on biking somewhere, but they want to head somewhere for lunch that's a mile away and difficult to get to by metro. So these bikes just very, very sturdy. So I felt like the risk of a collision is significantly lower with these kinds of designs.
Is there a separate infrastructure, routes and bike lanes and whatnot in DC? Because Tampa, Florida here, and doing this kind of thing in most parts of Tampa is taking your life in your hands.
Yeah, that's an excellent question. And the answer is yes, there is. And I could show a map, but I guess, do we have a map here? It doesn't actually show bicycle infrastructure. Previous iterations of this visualization did show some of that. But there are a number of bike lanes. There's a lot of pretty safe ways to get from any source to any destination, as long as you're pretty close to the urban center. I think that as one rides more and more, one starts to become more comfortable in various areas, and there are lots of places that I will ride now that I would have felt very unsafe doing so when I restarted riding as an adult 8 years ago. But in the urban center, there's enough traffic or stoplights at every intersection that vehicles are not going fast the vast majority of the time.
Keep zooming in a little bit more, Robert. I think I saw some green lines on the street.
Zoom in more.
Zoom-
Yeah.
Zoom in more.
Yeah, those are actually protected bike lanes on L and M Street.
Oh, perfect.
H and I think there's some kind of pilot program with reserved lanes. 15th has it says cycle track on it. 12th, I guess, has something there. 10th, maybe they're just coloring bike lanes. There's a variety of infrastructure.
Cool.
So as a part of the motivation here, though, for doing this project was the fact that sometimes you'll want to find a bike and it will not be on the dock that you want it to be on. And there are apps developed for customers, one of which is SpotCycle. And Spot Cycle essentially is a, I don't know if it's worldwide, but I'm pretty sure it's US wide anyway. You can get the app and you can find out where bicycles are available on docks in various cities. Now, it turns out that when I joined this system, and actually it was fairly recently that I got my first smartphone. So when I joined the system, I was a flip phone user, and the apps
retro.
had no SMS alternatives. Unlike metro and bus schedules, which had been around for decades, the app developers didn't see the need to cater to such a small percentage of their customers that did not have location services and did not have geo visualizations on the fly. So one of the reasons I started investigating this data was actually to build myself a tiny little app that could do that for me via text message. So I don't want to spend a ton of time on this because we haven't actually gotten to the to the main topic here. But let's see. So this is back in the days of days when I was learning Python, coded this thing up, and George has volunteered to be a guinea pig here. But the basic idea is that you will just text a street address. You can text a street address to the app, and it will do some geolocation, figure out where the stations are, interface with the system data, and determine where the stations are nearby and which ones have bikes on the dock and what the number of those is. So I'm not sure if it's even running now. Yeah, it actually, okay, this is the app running in the background on my system here. Did you want to try to test this out, George?
Yeah. Or maybe I can show the one that we did earlier just to get an idea.
It's not the fastest. It's pretty primitive. It's just using Google's Gmail API. Sometimes it takes a good minute to respond. It checks the messages every few minutes.
So you want me to text an address right now?
Yeah.
Sure.
So when I first developed this, I would just basically leave it on when I left home, and then I could text this email address to find information without needing to check any other sources, and it would all occur via SMS. All right, so the little feed there says received message from George Zotto. Shows you the binary equivalent of what it's going to send him back. 1900 P Street, Northwest Washington, D.C., which is an address that doesn't actually exist, but if it did exist, it would be right in the middle of DuPont Circle. So it's Google has auto completion and essentially figures out where any address is if it would exist in the DC area. And presumably at some point in the next few seconds, George will receive a reply.
I got it, yeah.
Got it. What does it say?
I put in the chat.
Okay.
Massachusetts and DuPont Circle, Northwest, 20th and O Street, 18th in New Hampshire. Very close.
Cool. And it also tells you the number of bikes on those docks. The two numbers in parentheses at the end are number of bikes and number of empty docks.
Ooh, got it.
Again, I was only worried about communicating with myself, so I didn't feel the need to send extra characters in the messages. As soon as I knew what I was getting, that was all I needed.
How timely is that information? How close do they keep that 22 and 23 and 6 and 13 up there?
So you're talking about, I haven't looked at George's text yet, but I'm
It's just the number of bikes on the docks, the number of empty docks. How often do they update that information?
sure. Where am
Out of curiosity.
once a minute, I believe. So 22 bikes, 23 empty docks. This is a big dock. That one has 45 spots.
Do you know how their stations are transmitting that data?
Every kiosk is solar powered and is wirelessly connected to something.
Okay.
I don't know. I do know that they occasionally one will go offline, but and actually once I was riding somewhere, I think I was riding to something in Crystal City, docked a bike there, and when I tried to take another bike later that evening, I was denied the opportunity to take a bike. I tried multiple docks actually within a block of each other, and eventually ended up calling customer service, and they told me that my account was blocked because I hadn't returned the previous bike. And I said, well, no, I did return the bike. I returned it right here to this dock, and I guess they knew that one had been offline, so they just kind of credited my account and let me take another bike and sorted it out. All the bikes are uniquely identified, so I'm sure it was easy to figure out in the end when things came back online.
Awesome.
Cool. So this all kind of got me thinking that it would be fun to investigate this data set further and to try to use it as, at the time, an academic project in the first ever machine learning class that I took. But since then, it's just been an opportunity to continue to learn more about the subject. This year, I decided, as I mentioned earlier, to revisit it. And the data set has changed quite a bit. So what I was going to do is just show a few notebooks that I have put together so far. Really, at this point, just looking forward to getting into the real modeling. But first of all, I want to familiarize you with where I'm getting the data and what's available. So I wrote up these 3 notebooks here. They're at this GitHub site, which is, I don't know if it's been chatted already, but I'll just drop that link into the chat.
Thank you. There was a question about that. And if you don't mind, next time you go to the notebook, just zooming in just a tiny bit. Just one.
Sure. Let me know when we're good.
Robert, could you tell us, you said the earlier code was written when you were just learning Python, or could you while you're doing this, show us what you would do now that's different from what you did then, or like even in a very general way, like what was amateurish and what's cooler now?
So I think the very short answer to that question is that the data set had changed enough that I ended up just deciding to rewrite everything from scratch. Because a lot of the earlier code that I had written not only had the format of the data changed, but I had not been smart or forward thinking in figuring out, well, how would I store this data, make it more robust to new processes? So what may be a better answer to that question is just to show you how I'm approaching it now, and I can kind of talk about things that I did differently previously while we're going through it.
Exactly. That's exactly what I'd like to know. Thanks.
And probably when you wrote it, you were using Python 2, now you're using Python 3, Robert?
That is true.
Cool. All right. Let's look at the data.
Okay, so data acquisition. So first of all, maybe I should say what the question is here, what we would like to do is be able to predict when a station is empty or full. Said another way, if a station has 1 or 2 bikes on the dock presently, what is the chances that there are still any bikes there in 10 minutes? What is the chances that there are still any bikes there in 5 minutes? That is how I'm thinking about the problem. That being said, these 3 notebooks don't yet get us to that solution. But I still think it's a good point at which to solicit feedback and show you how I'm thinking about this problem. So to answer that question, we need to figure out what data we have available and what the usefulness of that data might be. So I identified a number of sources. There is a trip history published by Capital Bikeshare. There is also a history of the dock status, meaning when stations were empty, when they were full, and etc. We know that DC area weather is likely to play a role, so I figured that would be an important data set to get. And also a history of the calendar, just knowing information about the time of day, days of week, which days are holidays, weekdays, weekends, would be useful. What real-time data might be interesting? Capital Bikeshare's trip history is not available real-time. It's only published after the fact. Capital Bikeshare's dock status, as we saw, is available real-time. And weather and clock information are, of course, available real-time to some extent, too. So there's just a number of get-started methods here. Helper function, just read a SQLite database, figure out what the names of the tables are. Read a SQLite database, figure out what is the most recent timestamp in the database. Don't know if I mentioned up top here. Yes. Design considerations for the data acquisition. One thing that I wanted to do differently this time that I did not do the last time was allow it to be updated periodically without having to run all of the data acquisition again. So if you run it a week later, you're going to have a week's extra data, but you don't want to have to collect the last 10 years again. That requires some thinking on how to do that. I've got a boilerplate here that essentially solves that problem. Otherwise, my design consideration for the data acquisition was I wanted to modify the input data stream as little as possible. Really wanted any processing to be done after the acquisition stage, but keep it in as raw a form as I can right now. And I want the data collection to be as robust and adaptable as possible, as in the data formats sometimes change. We want it to be adaptable to that, and I'm willing to sacrifice efficiency for that. So
That's a good trade-off there, by the way.
Oh, right. So it takes a few extra minutes to execute the code maybe, but it's not something you have to do all that often.
Yeah, and going for efficiency first is known in the trade as painting yourself into a corner. Or premature optimization is the way you put it.
Right. Now that being said, maybe I presented that a little overly sanguine, as if I had considered that in advance. Right?
Shh.
One
It's a secret. Don't say anything.
Exactly. For instance, this read trip history function here has been modified a few times as I realized that it was not capable of getting all the data that I thought it should have been. The reason for that, so these are actually stored at S3 buckets. Capital Bikeshare has on its website a page system data. The URL capitalbikeshare.com/system-data. And trip history data, every quarter we publish downloadable files. And this is what it looks like in the interface on the URL. Zip files here and there for the earlier years. As the total numbers increased and the zip files increased in size, finally we get them month by month instead. And that continues to this way. And I opened a number of them, saw that they contained just a file with this same name .csv on the inside, and wrote the scripts. And first thing, of course, I find that I'm not getting all of the data. And so, okay, crashes here and there. Why does it crash? So these ones, 2012 to 17, actually had the data separated by quarter. So there were 4 different CSV files inside there with different names. And I ran it again, and at some point I get another missed month. I think it might have been 2019 July, that for some reason the file name on the inside, in spite of being a CSV, did not have the extension .csv. So the first few iterations were really just about trying to make this function able to get more and more data, stop looking for things like .csv or particular file names. Still not robust to everything, so do have a part in the EDA later that does check to make sure that there's data collected from every month at least. I think I just discussed those challenges. One challenge that I did not discuss is that the format within the CSV abruptly changes in April of 2020. And that requires totally different column names. So another reason that I built the code to be kind of agnostic towards column name, just throw it all in a data dump and then try to make sense of it later. Just collect what's in the files.
Robert, just a quick question. So how many data points are there? How many trips like per year or total?
How many trips per year or total? So the total number of trips through the end of 2020 in the database is 28 million something. I think we'll have a little bit more information as we get into Notebook 1, which does some of the data analysis. But that's the total number of rides across all of these Amazon files. Another thing for anyone who's not familiar with downloading from Amazon buckets, turns out that this one being a public bucket, I didn't actually have to provide my login credentials at all. So I found a method for getting in via disable signing. Not really much more to say about that, except that most uses of S3 buckets, I believe, are not public and do require a somewhat different access code.
And the CSV files, what do they look like? Like source, destination, duration? Or are you going to cover that later?
I'll cover that later.
Oh, perfect. Thank you.
This is really just the acquisition pipeline that I'm not going to show much about the data in Notebook 0, just how it's acquired. Outage data from Kaggle Tracker. So I met a guy at a DC area meetup several years ago, Daniel Golke, who had built a pretty awesome tool, cabbytracker.com, and it's still online. I believe the map functionality no longer works, but the information that one needs is still here. By outages, what we mean is a station within the system that either is empty or is full. So this is the list of current outages. I guess this page has been open for a couple hours. I could refresh it, I guess, but it's probably similar. So these stations here have been bikeless or else full for this number of, I think that's minutes. It's interesting, actually. I've kept an eye on this every now and then, and it's interesting sometimes how some stations will. This station here has not had a single bike on it for 4 weeks. It's not surprising that the stations where this happens are in the fringes of the system, where maybe there's fewer people riding them, so there's less likely to have someone show up. Anyone who's familiar with the area will note that these first three here are all east of the river, in neighborhoods that are a little bit lower income than the average DC neighborhood. So interesting observation. Not sure if that means anything. The opposite is true here. Fessenden and these two along Wisconsin Avenue are very close to Chevy Chase, which is one of the wealthier parts of town. But I have noticed over the last few weeks that when you do see a station that stays here for a long time, it's usually in a fringe area of the system where there's not a lot of volume in general. And then for whatever reason, it seems like these top candidates over the last few months have often been in east of the river locations. So, okay, what else did I want to show on Outage Tracker? You can get, this is the current outages, but you can also get the history of outages, or status history.
Robert, I might have missed it, but outage means that the dock is full. Is that an outage?
Outage is either empty or full.
Oh, okay, thank you.
So it'll say status here, empty, full. An empty dock means you show up, you might not get a bike. A full dock means you show up with a bike, you might not be able to park it. So either can be a significant inconvenience for a customer, and it's to the operations, the management's best interest to keep the bikes as well balanced as possible. So having a prediction model that could predict in advance where ridership is likely to be heaviest has business value in that sense.
Mm-hmm.
I will note that this is the current outages, and I believe this one may be the past outages. No, this is graphs. I think that might be the... Yeah, this is where you can actually download earlier data. So anyway, getting back to the code, in order to get information about when systems have been, or when stations have been on and offline, I realized I needed to read both the current outages and the past outages. And I don't think there's too much to say about this. It's a URL that you kind of build through sending parameters in this fashion, start date and end date. If you request too much data, it will fail. I determined that just requesting 7 days at a time was the best way to do it. It's also a pretty small website, and I'm not sure what the server is, so didn't want to burden it too much and decided to throw a little sleep in there between each request. There's some differences between the past outage data and the current outage data as well that I looked into a bit in my own EDA. I don't think it's in the portion that I'm sharing this evening. So weather, another very important data set to include here. You can get weather data from any number of sources. I found this site, visualcrossing.com, which is a small business operated out of Reston, not far from DC. They had archived data from a variety of locations for quite a few years, and a very simple API to use. You essentially get a key and URL base. Again, you're building a URL in the same way that you were previously, just sending parameters after the question mark. What I did here was built, since there's a lot of parameters to send, just put them in a dictionary, one of which is my API key, which is read from a file separate to this one. And you do have to pay a little bit if you request more than a very small amount of data. The advantage for me here was that I was requesting data for only one location. I figured just getting one location, downtown DC, would be sufficient to summarize the weather data for the entire DC region. We do have small microclimates here, but nothing compared to the overall diurnal or annual variation. Not to mention that the vast majority of the rides are in the urban center anyway. So I think to get 90-some thousand records, 90-some thousand hours over 10 years, it cost me something like $8. Also found a library on PyPy that might be useful to someone if you haven't heard of it. Holidays, very simple. Really just import holidays, and it returns a dictionary of holidays. I think we can see that over here. In fact, if I go up to the EDA notebook, I think what I could have been doing was showing the data frames as we were going. So to go back in reverse order now, the holidays look a little bit like this. This is just converting the DC holidays from the year 21 into a data frame. It's really just a date object and the name of the holiday. Here is a sample of the weather data. This is the first 3 head and the last 3 tail observations. A lot of information here. Temperatures, dew point, humidity, heat index, wind info, precipitation, snow depth, visibility, station info. Actually, by requesting an urban location, it compiles information from a variety of stations. And I don't know if it uses some kind of averaging or what, but it reports for each observation which stations were used. Usually it's the stations at DCA National Airport, and I think sometimes there's one at Andrews Air Force Base. There's one at Davison Army Airfield, Fort Belvoir. I think there's one in College Park that sometimes shows up here. I looked into it, but didn't investigate it too far. Latitude and longitude are the exact same for every point. Resolved address. We get sunrise and sunset information, moon phase, and conditions. Going up to the current outages. This is from Kaggle Tracker again, the website with the Bikeshare dock empty and full information. This one. I collected this all at one particular timestamp, so these timestamps are all just whenever I collected it. This version, I guess, is from over a month ago. Station ID, name of the station, the terminal number. There's actually 2 identification numbers for each station, which is interesting and became a real mess at one point in the analysis. Status, whether it's empty or full, location, bikes available, etc. This is the past outages. You get slightly different information, not as much about the dock count or bikes, but you do get qualitative information like empty releasable. Sometimes it says near empty. When there's 1 or 2 bikes left, it can say near empty. And our trip history, which was the very first thing that I downloaded from the S3 buckets. Here we have the head of the trip history, the first few rides in 2010 September. Duration, start date, end date, start station, end station, an identification number for the bicycle itself, and member type, which is either member or casual. Member type refers to what the person's relationship is with the with their Capital Bikeshare membership or key. I believe the annual and monthly members are called members here. And if you get a daily membership, a single ride, a 3-day membership, or I think that might be all they offer. 7-day? I can't remember. Those are all called casual members in the dataset. There is some significant difference in ridership patterns between those two classes of members. As a very gross oversimplification, those who are labeled members are typically residents of DC, and many of those rides are used for commuting and transportation. Those labeled casual are often first-timers to the system. Sometimes they're residents of DC, but in many cases, these are recreational rides. You'll find a disproportionate number are initiated in the touristy parts of town. And then you'll see a lot of empty data over here. And the reason for that is the fact that the formats changed between the start and end of the dataset. So tail of the dataset is over here, where these early rides or these early fields are empty and these later fields are full. So as part of my acquisition process, I just wanted to get all the information in whatever the field names were called, pull it in, be inefficient, but get everything, and then sort it out later. Not so big that this is infeasible at this point, even just on my hard drive.
How big is it, by the way?
The entire database here. So what I didn't say earlier, but what I did on file 0 here was wrapped everything up in this put it all together function, which essentially writes it to a SQL database. And that database was 5 gigabytes. And here, again, inefficient, just pulling these select star queries, which takes some time. In fact, reading the trip history, which is the lion's share of the data, ran in, this is the time in seconds, so about, 8 minutes to read it. But we have all the information here and can condense this into a better format further down in this notebook.
I like using SQLite.
So I was actually curious on that. I defaulted to it because I had used it before, and because I had used it before, it was easy. And because I wasn't super concerned about efficiency, I didn't care that much. But if there are better solutions, I would definitely be all ears.
No, SQLite's a good choice for something like this. It's embedded, it's single-threaded, and if you get a little bit choosier about the schema, then you can reap some gains in efficiency, but do it right first and then make it fast.
Yeah, that was my approach anyhow.
It's a good one.
This isn't something that has to be run real time, so not a concern.
Nice.
So now the data cleaning, and if you're looking at the table of contents on the left, you can see that that's the vast majority of this notebook. There are a lot of issues with the data here. I don't address them all, but I'm looking at the ones that I thought were the most important. So we'll start with, I guess I could renumber these things here, but essentially I wanted to solve the major problems and then ignore or discard anything that was too difficult beyond that. There are a couple of cases where doing so does probably introduce some sampling bias. I tried to be cognizant of when I'm doing that and why. So to start with, format mismatch. That's what we talked about earlier with the trip history. So we have all the rides before April of 2020 have these field names, and all the rides after April 2020 have these field names. And this is the dividing point here in terms of the road number. So mostly they contain the same information. There's some information that is present in the latter format that was not in the initial format. If I had to guess, the reason for changing formats is one or maybe both of two things. either for consistency with formats used by other systems, such as GBFS, which I've somehow been remiss and not mentioned, but there is actually a standard data format for bike sharing systems, and it is here, General Bike Share Feed Specification. So the data that Outage Tracker is pulling to get that dock status information is all in this GBFS JSON format. And if you look at the format, it has some header JSON, which is just basically a bunch of pointers to other JSONs, system overall information, system, here's information about each station, station status. Those are really the three tables that have the most information, or the most useful information for me. Station information contains static information about a particular station, its latitude, longitude, capacity, and anything else, and the name, ID numbers, stuff like that. And station status is the one that updates as bicycles are put on or removed from the dock. So, and we'll have a much better view of these two JSONs over here in the Jupyter notebook. So it could, so I interrupted myself there. It was, the format may have changed because of that. I'm not sure if that's why. Another reason that they may have felt the need that they had to change the format was because now in 2020, they started introducing dockless into the capital bike share system, which meant that the old format where you just had a station and the station number were insufficient. You also needed to have a latitude and longitude in case the bike were deposited somewhere that was not actually at a dock. However, by moving to the new format, there are a lot of other things that are different as well. So a number of rows here about just combining things that looked equal and discarding some things. There are a few columns that didn't look terribly useful for this analysis. One is equity. Only 1 month included that in the data stream. Highly imbalanced binary feature. I think it's meant to capture a Boolean based on whether the customer was someone who was part of a program that is specifically attempting to help defray the cost of ridership for lower income communities. Rideable type is classic bike versus electric bike. I'm going to discard this, but there'll be a little bit more on that to come. Ride ID and bike number, interesting maybe, but I discarded it. And I'm getting rid of the lats and longs because I will end up, for my analysis, discard all the e-bike rides just to keep things a little simpler. That is definitely a potential source of sampling bias. It, at this point, is a very small part of the data set, but something to keep in mind if this project, or if this type of analysis is goes forward. Let's see. So after recombining, we now have a start time. So we have a time, station number, station name, time, station number, station name for start and end, and the calculated duration, which, or actually no, the given duration, which occurs in the first half of the rides but is not present in the second half. I kept that, and the member type. So now my next question was, okay, what data is missing? Some rows have member type unknown, very small number, only 58 such rows. When I looked into that a little further, I found that the most recent such ride was actually more than 6 years ago. And with only 58 such rows, and me thinking that I might want to do some analysis to differentiate the members versus casual, I ended up just discarding these 58 rows. I looked at them. They didn't seem like they were out of distribution at all in general. So then we come and look at, okay, what are the nulls? A lot of them are missing a start station number. A lot of them are missing a start station name. Thankfully, those all seem to be the same rows. Same with the end station number, and many are missing duration. This is all the ones after April 2020 that did not include that. So I wanted to take a look at the ones that are missing duration. What's going on with those? Let's see. So I ran a calculation from the start and end times. You can compute the duration. Put that in a separate row here, or separate column here, calculated duration. And usually it looks like it lines up pretty well with the ones that have a duration. And now we have durations for ones that didn't have durations. So far, so good. Let's compare the duration against the calculation, see if there's anything askew. And what do we get here? So the vast majority of them are within 1 second. That's great news. And what else is going on? We have a bunch of them that are an hour off in one direction or another. So why might that be? Well, it turns out that the answer is due to daylight savings time. What I believe is going on is that the durations, when they are present in the file, are actually correct, but the date times themselves have not been encoded for DST. So sometimes you'll get a ride that, say in March, when the 2 o'clock hour does not exist one night, you might get a 10-minute ride that starts at 1:55 and ends at 3:05. And by calculating the duration, it looks like a 70-minute ride. So just kind of verified to see, okay, that's what's going on here. Decided to do a fill NA, which puts the calculated durations only into the rows that didn't have a duration to start with. Calculated durations looked fine for the most part. And the only part that should have this daylight savings time problem where we don't have the provided durations would be November of 2020, the fallback hour. So I took a little bit of a look at that just to look at these 25 rides here, I guess. Would be a little bit easier, I guess, if I zoomed out and we could see it full screen, but I won't do that because I don't know if that just makes it too small to see. Yeah, the negative rides from this portion are all attributable to daylight savings time, to this fallback phenomenon where a ride started at a certain time, 1:21, and ended at 1:19, but it was, instead of being a 90-second ride, it was actually 90 seconds short of an hour. So a little bit of analysis in here. I guess the upshot of this was, one, we wanted to figure out what to do about the daylight savings time for the prediction model itself. And two, I wanted to do a little bit more investigation into the distribution of ride durations throughout the entire data set. So this is a value counts on the duration. They've been binned by minutes. And we see that the most common length ride is 5 minutes. And this, get down here, I think I plotted it not too far down. Yeah. Histogram. So not too many rides of extremely short duration. Not too surprising. If you want to go from one station to another, you actually have to make that transit. But most rides are quite short. And then there's a very slow fall off here. One thing that surprised me was not seeing cliffs at the cutoff times. So for instance, if you keep a bike for less than 30 minutes, it's no charge beyond whatever your membership cost was. But if you keep a bike beyond for 31 minutes, you pay $2 on top of that. For someone like myself who has always had an annual membership and uses it for hundreds of rides a year, that changes the cost per ride from being 20 cents into significantly more. Not to mention, it's kind of pointless because there's plenty of stations and you can always just go to one place, put a bike on a dock, stop there for a few seconds, and then pull the bike right back off the dock, and you've started your clock again. That pricing scheme is not intended to discourage people from taking longer rides. I think it's to encourage people from keeping bikes that they're not using, which is one thing that I noted could have been useful in Stockholm when I tried the system there. I think they had a 3-hour limit for free usage instead of 30, and it incentivized us to actually stow the bikes in our hotel room while showering one night, I believe, because we thought that we would lose them otherwise, because the dock was actually empty just outside the hotel. That kind of thing would be more discouraged in DC, where you have a 30-minute time. So I wanted to look at these very short rides as well, because I was surprised to see so many rides of 0 and 1 minute, especially given that the initial information I had about the dataset was that it had been pre-cleaned to some extent, such that rides that started and stopped at a single location and were returned immediately were supposedly discarded, although I'm not sure that they were from this data because I found a number. In any case, I wanted to look at the rides that were extremely short. This is just another view on that same. It's not another view of the same histogram. It's a fraction of the number of rides that are returned to the same location they started in. So if you look at 0 minutes, 24,000 rides, 18,000 of them did not go anywhere. So 3/4 of the rides given for 0 minutes length started and ended at the same location. That dips significantly when you get down to the 5-minute rides. People are actually going places. And then these really long rides, it actually goes back up. I think this is capturing more of the casual ridership crowd where people just find a bike on a station, want to ride around maybe aimlessly for a while, and then return it. So there's two very different types of uses for the system.
It's an interesting chart, yeah.
So I found there are 6,000 rides, though, where the start did not equal the end, but the duration was less than a minute. And that surprised me, because at least in my neighborhood, there was no way that I could ride between any two stations within a minute. They're just too far away. So I made a subset of the data set. I guess I called it teleporters here, which seemed apropos. Anyway, we found that there are a number of rides that fit that criteria. I don't know if I plotted them all out here, but I kind of wanted to get an idea of what was going on there. So these are all 0 minutes. This is the seconds. Some of them are clearly bad data. These are going completely across town, 4th and K northwest to 1st and M northeast. That's actually not that far, come to think of it. That's pretty close. But still 0 seconds. It's clearly not correct. There are a handful of rides that are almost certainly true rides here. 5th and K to 5th and Massachusetts is maybe a block at most, maybe 2 blocks. That's 54 seconds. That one seems reasonable. 18th and R to 18th and New Hampshire, that one also seems pretty reasonable. Those two stations are very close to each other. 50 seconds is reasonable for that one. So when I looked at all these, I thought about half of them were probably correct. I think less than half of them. In any case, I decided to just discard the 0 minute rides.
May people hack the system?
Excuse me?
May people hack the system?
Hog the system? What do you mean?
I mean that they can change what time they used.
She means hack. People may be
Hack.
hacking the system.
Sorry.
they can change what time they used, as in cheat the system so that it looks like they're keeping the bike for less time than they are?
Yes.
I can't definitively say that people can't hack the system, but I can say that I've never tried it, and I'm not aware of anyone doing so.
Robert, they look like they were in April. The ones I saw could that be a daylight savings time thing?
No, and actually I noted that too, and thanks for pointing that out. It isn't. What it is the fact that all of these 0-minute rides are occurring after April 2020, which I think means that before April 2020, the people provisioning this data were pulling those short rides out. They were cleaning the data.
So they stopped cleaning it?
I think they stopped removing these short rides. I think and we're just looking at the head of the file. So we're just seeing the first few rides from April of 20 that match that condition.
Right.
So I ended up discarding the 0-minute rides. I think in many cases, considering back to my own experience, sometimes I might go to a station, pick up a bike, decide that there's something wrong with the tire, turn it back in 10 seconds later, and then try another one, and end up trying 2 of them before I get out of there. That's going to show up as increased demand in my analysis if I don't remove them. So I don't know how it's a significant fraction of the 0-minute rides, but those are of course a pretty small fraction of the overall rides. So probably not important overall, but I ended up discarding those rides. Any other questions about duration?
I think we're good.
Okay. Missing locations. A lot of rides were missing the location information. Start location or end location. Why might they be missing those? So if we look at the missing location head and missing location tail, we'll again see that the head on missing location is April of 2020. So all of one's missing location came from the new format. And we'll see that sometimes it's missing location on both ends, sometimes it's missing location on one end or the other. So the major effect that's going on here is that there is an association between the ride's missing location and those which are taken on electric bikes. The ones missing location are an extremely small fraction of the rides not on electric bikes, but over half of the electric bike rides. And I think this is just because those ones don't have to be docked at a station, and when they are not docked at a station, they are shown as missing station. So there's a number of ways one could handle this. For simplicity, I ended up just deciding to discard these 100 and some thousand rides that were taken, that were missing origin or destination. I don't remember if I also just discarded all the electric bike rides for a similar reason. Again, definitely introducing sampling bias, but it's a pretty small fraction of the data set overall, although growing. So something to keep an eye on. So I also wanted to look at the distance traveled against ride duration. Before I could do that, I needed to fix this problem with the identification numbers of the stations. I needed to be able to map these strings or these station numbers to actual lat long on the ground. And it turns out that there were 2 different types of ID numbers used when I started the reworking of this project back in December. It turns out that in January, after I had dealt with this and spent many hours actually trying to figure out this whole problem, The data ended up being fixed at the source, and now we're all based on one set of numbers, and it's so much easier now. So some interesting issues with the numbers. Sometimes a station name will change and the number doesn't. Sometimes the station number will change over time and the name doesn't. Did a bit of a deep dive on that I'm not going to go through. One thing that I thought was of personal interest is that when I first started as a customer of this system, I used to live in South Fairlington near this station that was located at the 34th Street Bridge over the Freeway 395. And I wasn't using Bikeshare that often at that point, but I moved out of that neighborhood in 2014. And at some point in the next 2 years, I realized that that station had disappeared. So while the vast majority of stations have remained in place after they've been installed, a few of them have disappeared for one reason or another. I like to think it was that I was personally such a large percentage of the usage of that station that it just did not make economic sense for them to keep a station there once I moved.
That's funny.
But I think I haven't actually looked at the data, but I'm pretty sure I'm a small percentage.
Should have renamed it Robert Station.
Anyway, it disappeared. What was weird about it, though, was you can actually log into your personal account and check your ride history. And when I did that, I found that those rides had not disappeared from my history, and that, in fact, that kiosk number had been moved to a new location. And all of my rides in my history from my first year as a member now show up as if they had started at some other location, which is possibly problematic for trying to use this to do location predictions. It's a small number of stations that are affected. In many cases, like this one, the usage patterns probably aren't too different at these locations. In some cases, you did move from a very residential area to that station also moved out of Fairlington, and Gravelly Point got that station. The rides are shown as the same number. So, but this Gravelly Point station is going to be much more frequented by tourists and casual riders. Gravelly Point is a park very close to the airport, but it's right off the Mount Vernon Trail and gets a lot of recreational traffic, whereas Fairlington is a residential area. In any case, I uncovered a few issues like that, and I'm sure that there are probably others that I don't have personal knowledge of where the station was originally, because there's no information in the present data set that will tell you this station ever used to be here. I just happen to know that based on looking at my own ride history. In any case, I decided to ignore all that, assume that the current station locations were good for the duration. I am going to throw out 3 warehouses. I think, where was that? 32901. I think there's a couple other that are warehouses for the Bikeshare system and not actual customer locations. In any case, did some cleaning on this stuff. Some more analysis of stations there. Skip through that. This is the code that I actually used to end up getting rid of all those rows. The member unknown, the duration less than a minute, the ones without start and end stations. Then verifying, hey, good, now we no longer have missing data, which was the whole point of that exercise. So moving into geospatial, did a little bit of look at the distances of rides, which stations were most popular. This could be of interest to some locals, perhaps. Some code there. I'll skip through most of this. some observations about Panda's sample being much slower than NumPy random sample. I took a random sample of stations to enable plotting, a random sample of rides, rather, just to get a sense of the distance traveled versus duration of ride. These ones that have the same start and end point are shown here. And the distance is always as the crow flies distance between the lat and long quoted. So the distance on the ground is certainly longer in one form or another. This is in miles. This is in seconds. So a few outliers here. Not sure what happened. Somebody may have loaded a bike up onto a pickup truck or something and driven it a couple miles in a couple minutes. But most of them follow a pretty clear pattern. A few stations that no longer exist in the GBFS data, I decided to discard those because it wouldn't be useful to predict rides at places that don't exist anymore. So my eventual goal here is to bin all the data into a data frame that shows essentially the rows are times and the columns are locations. So I want to know what is for each hour, I'm binning by hour, what is the number of bikes removed from station X during that hour? So ends up being a pretty big data frame. We have, this is the number of non-zero entries. First of all, I did a group by because that was pretty fast. Looked at a few of the outliers, trying to figure out what the limits are here. The highest number we see at any point is that 119 rides started at station 31209 at 7 o'clock on some day in October of 2012. This is, I didn't really describe this, but this is year, integer day of year, from 1 to 365. I think 1 to 365 or 366 if a leap year. 19 is the 24-hour time in hours. And this is the station number 31209, First and N Street Southeast. It turns out this was right at the end of a Washington Nationals playoff game against the Cardinals. So that is certainly the reason for that one being an extreme outlier. And another, the busiest end station number, 125 rides, ended at the Jefferson, no, not the Jefferson Memorial, that's Jefferson and 14th, that's near the Washington Monument, but it's cherry blossom traffic. This is the 90th day of the year, which would be March 31st, probably. Looked at a number of these and found that there was a pretty easy explanation for almost every one of these really high ride numbers when you dug into it. Many cases, they're dominated by cherry blossoms. The Women's March that occurred the day right after Donald Trump took office, protest march. Many of them are arrivals to Nats games. Some of them are departures from Nats baseball games, 4th of July weekend. And 2019 November 2 was the only one that gave me a little bit of pause. I couldn't figure out what it was until I Googled it and saw that it was the Nationals World Series parade. And at that same location, right outside the Capitol building, there was also apparently a Second Amendment rally that day. So I'll let you guess as to which one might have been the source of the bicycle traffic. So in any case, I come down here, I create my arrays, bike and dock. Let's see. Just another visualization before we leave this page here. I think I showed this in the meetup page, but just to get a sense for the problem in a visual perspective, this is the aggregated number of rides taken during the 8 a.m. hour. This is the aggregated difference in rides that are docked at the station minus rides that are removed from the bikes that are removed from the station. So this is during 8 a.m. aggregated across, I don't know if it's the entire data set or just I think it's just weekdays. In any case, the green mean that they are sinks and the red are sources. And you can definitely see which neighborhoods people are commuting to and which areas people are commuting from. And in particular, which stations are likely to be the ones where the outages occur. So you'll see that where I was coming from over here in Arlington, I was actually pretty fortunate as a regular rider that just didn't have this imbalance for the most part. I mean, the magnitude of it was much smaller. Typically, if I wanted to take a bike off of a dock in my neighborhood, I could find one at any hour. But I knew that my friends who lived in these neighborhoods up here in town, or anybody who was trying to go around downtown during rush hour, you would be affected significantly. So I may have had less use for my own personal app than many others would have. Let's see, weather. We didn't really get into that. Any questions about the Bikeshare data or requests? I know it's already 8:40. Been kind of going on at
Yes, sorry. I'm curious how this bike usage rate is checked against map of campuses, university campuses.
So, interestingly, I don't know of much. I don't think you'll find much that is interesting on that in the DC area, which is surprising because there are a lot of university campuses, but they are either completely obscured by the commuting phenomenon, such as George Washington University here, or they are in further out parts of the system where you just don't see that much going on. In many cases, an entire campus will only have one station as well. So you don't often see, you would think maybe students arriving. I do think you'll see, so here's Georgetown University. There's definitely heavy arrivals at 8 a.m. there. But I think that is an excellent question, and I find less of an effect at the DC area universities than you might expect. We did mention earlier in the meeting that College Park is out of the system, and that's probably the biggest university in the immediate DC area.
I see. I would assume that students' places like university campuses are more active during daytime of usual peak hours. But probably students use their own bikes. And
I think that's right. I think students are more likely to use their own bikes. The other thing that one should keep in mind is that because of this phenomenon, anywhere where ridership is heavy, anybody who's serious about biking is likely to use their own bikes. I mean, I got away with using this a lot because I lived over here and didn't face this outage problem as often. But I also put probably more miles on my own bikes than I did on Bikeshare bikes over the last 5 years. I'm sure of that. It all kind of depended on where I was going. If I was heading to a place not close to a dock, I'd take my own bike. If I was out for recreation, I would almost always take my own bike.
Yeah.
But Bikeshare was super useful for going if you wanted to go downtown and spend the whole day, or go to a crowded part of town. You could leave, just take the Bikeshare there. Don't have to worry about whether you're going to bike home or whether you're going to metro home. Also, you don't have to worry about your own bike getting stolen if it's in a particularly theft-prone part of town, and there are some of those.
As Puran is saying in the chat that universities usually have their own shuttle system, so maybe students use shuttle instead of bikes, especially in the winter.
That could be.
And explain to me the difference about this imbalance real quick, Robert, if I understood correctly. So you said source and destination. Does that mean that most of the green ones, the majority of them are destinations? Is that why you categorize them as green?
So yeah, so what I did here was only selected rides that started during the 8 a.m. hour.
Oh, okay, specific. Got it.
I think I kind of glossed over that, but
There.
during the 8 a.m. hour on weekdays.
Okay,
And
perfect.
we're looking at net inflow to a station.
Okay.
So the green stations are accumulating bikes during the 8 a.m. hour, while the red stations are shedding bikes during that hour.
Got it.
And the opposite is true in the evening, which should be to no surprise. These stations will quickly empty out in the evening, while these ones here are more popular destinations, and Capitol Hill too. One thing, the phenomenon is actually less strong in the evening. There may be two reasons for that. One might be just that the evening rush is a little bit more spread out than the morning rush. I think evening people sometimes stay near the offices, maybe they work late, maybe they go out afterwards. They're not always traveling at the same time every day. Mornings maybe a little bit more consistent that way. The other reason that you might see more of an effect in the morning here is because these stations up here are at a higher elevation than the stations down here. And there are certainly some people who are going to ride one direction because it's easy, and maybe we'll take Metro back home because it's not easy.
That makes sense.
One thing that I found interesting in the EDA, which I didn't put as part of this notebook, is that if you look at all the rides over the course of the history of the Bikeshare system, you actually find that the average elevation at the start station was something like 8 feet higher than the average elevation at the end station, which is actually kind of amazing when it's aggregated over that many rides. So it really shows that there is a preference to have a net downhill for whatever reason. So what that does mean is that the people who are in charge of rebalancing the system, so I didn't talk about this, but there are vans and a team of people that work for Capital Bikeshare that try to balance the system out and keep it from getting too lopsided, to help customers, to help make it sure that you're turning away as few customers as necessary. So one thing that they do actually during the morning rush at a few of these street corners down here, they'll have a team of people that are just accepting bikes, and you don't have to find a dock. You can just be guaranteed that you can deliver a bike to this location every day. And they are rapidly collecting bikes there and then dispersing them as the van goes in and out, taking them to docks further out, presumably in these neighborhoods up here, which are rapidly emptying out at the same time.
That makes sense.
So if you can put, I think generally the van will carry 25, 30 bikes or so. So you can put that many bikes in the van, carry them back uptown, and presumably you lose fewer customers to Metro and Uber and scooters and other alternatives that way.
Yeah.
Robert, have you shown this to anybody at Capital Bikeshare?
Back when we had meetups in person in 2019, and I think the very first iteration of this, I did show at a meetup when I was in grad school, and there were Capital Bikeshare people there, and I chatted with them about it. I also showed my little spotter text messaging app to some people at Capital Bikeshare a couple of years ago, and there was some talk of that might be a useful thing to develop further. It never actually developed into a business endeavor, but it surprised me. I hadn't really thought of it at the time, but there was some demand for this information to be available on cell phones that were not capable of visualizing maps or of providing location services. So, in particular, they were Bikeshare staff at that point were investigating methods for trying to make the system more accessible to low-income riders.
Mhm.
One thing that you'll see if you look at, look at the busiest neighborhoods here. Columbia Heights is definitely a mixed demographic. Capitol Hill is fairly high income area relative. I mean, it's definitely changed a lot in the last 10 years, but it has been becoming more and more exclusive, I would say. But a lot of these stations over here in Wards 7 and 8 still get very little usage, as you can see with the tiny dots on each one.
Mm.
And I think there are a number of challenges for that. One is the fact that crossing the river here is a major barrier as far as safe routes and distances are concerned. There's only a handful of bridges. There are some side paths on the bridges that do allow you to, these are freeways, so you're not technically allowed to ride with traffic, but even something like South Capitol Street, where it's probably legal, you really don't want to. So I think that is a major reason why people will not use bikes over here. The other big reason is that these neighborhoods over here are far hillier than the rest of DC. So it's much more of a challenge. Ward 3 is somewhat hilly in parts up here as well. But you'll see fewer riders up here. This is also less dense area, but with the opposite income extreme, I would say, especially in these areas.
For sure. Yeah.
No, an interesting question, and that was at the time they were investigating ways of trying to explore ways that you might be able to make it accessible to people who couldn't afford a smartphone.
It's really
And-
interesting, Robert. Really interesting study, everything about it.
Yeah, it was something of personal interest to me, so I kind of gravitated to this data set.
Nice. Keeping track of time, is there anything, I'm sure you have tons of more content to share with us, maybe some key other ones that you want to share with us, Robert?
So let's see, we could discuss the weather briefly. Weather data set had a number of missing values and nulls as well. Do a describe on it, mostly. So heat index, a lot of missing values. Wind chill, missing values. Snow depth. There's good reasons for why those are missing, which I do go into further down. Essentially, heat index only gets measured if it's hot. Wind chill only gets measured if it's cold. And snow depth only gets measured if there's snow. But it does lead to the question of how are you going to treat this data? What I ended up doing was eliminating a lot of these columns, deciding to select only a few. Temp, which is the air temperature. In this case, you'll see min temp and max T. These are redundant. I think this is the 24-hour measurement, whereas I'm getting hourly measurements anyway, which is the highest sampling rate of the data source. So these are just going to be equal. I kept dew point. Humidity is redundant to temperature and dew point. There's a simple equation that relates them. So I kept temp and dew and removed humidity. You might, if depending on what kind of model you're fitting, you might prefer to keep humidity as it correlates with temperature a little bit less. For neural networks and other models, having some strong correlation between two variables is not a big deal. Wind speed I kept, but I separated it into X and Y components. Precip and snow depth I kept, and and wind direction. I kept that as part of this components. I think that was about it. I'd go into some detail down here on how all that was done. Pairs plot here showing those temperature and dew point correlations. The labels are, of course, completely invisible at this point. Now here's another one of temp and dew. Dew point should not exceed temperature, so there's some noise in the measurements there. This goes into the relation, just checking to make sure that the relative humidity was consistent with the two that I saw. A couple cases where the calculated relative humidity was too high, probably because the dew point was on the wrong side of the temperature. Same thing with the wind. Took a look at wind speed and direction. One thing I do want to mention, I know it's getting late and I have this notebook on models, which is very premature, and I didn't want to spend a ton of time on it because I'm really just getting started with applying serious predictive models to it. But one resource that I found very useful while doing this is this tutorial here, time series forecasting, which I might as well just throw in the chat.
Thank you.
Is this where they do that centering of the wind? Kind of normalize it to be in the center.
Yeah. Actually, yeah, and my models notebook right now basically follows these methods that are applied here and applies them to the Bikeshare data. There's a lot, I really dug into this page in detail, and it's a great place to start. There's a lot of the approach here that I would like to try to improve on. But I don't know. I mean, I think it would have taken me a really long time to get just to the point where I'm at without this resource here kind of helping to get my feet wet in TensorFlow, specifically for time series.
So maybe, Robert, in a future session, you can talk about the modeling part of this project if you're still active on it.
Yeah. I mean, I would love to continue this project. That's, I mean, the reason that I wanted to get into it was to start to apply some of the methods and approaches that we've learned here through this and other meetups over the last months and years. And I knew that I wasn't going to get there by this particular date, but I thought it'd be a good time to show what we have, at least at this point, get some feedback on the process so far, and hopefully go into actual regression modeling in a future session.
Yeah, that'd be great. Before you wrap up, anything else you want to show us, or maybe any call to action on how can the community help you or contribute to this project?
Let me see. As far as wrapping up this notebook here, it's probably somewhat self-explanatory. I'm not sure how well I commented some of what I was doing. The stuff with the snow depth and precipitation required some interpolation because measurements were only collected every 6 hours and I wanted them every hour. Pretty easy thing to do, but requires some pandas methods that are cool and useful to know about. You can find them in the notebook. I also found some really bad measurements of snow depth that made no sense. So did a little plot here to try to figure out this is snow depth, which is supposed to be in inches according to the visual crossing documentation and plotted it, scatter plot against the temperature, and realized that the snow depth in inches over 200 made absolutely no sense. We do get the occasional large snowstorm here in DC, but nothing like that. So I thought maybe the measurement units were wrong, but then I started looking at it and they were at the wrong times of year and everything. And it really looked like these were blips in the data that should not have been there. So I tried to come up with some heuristic to figure out which data points. I think I did it right here. Snow depth, anything greater than 30 inches, I threw out, and anything that had a month between April and October, I threw out. So that covered all the red points here. And then these other ones looked reasonable. You can certainly have snow at depth in the temps in the 50s and 60s if it's melting. In any case, I just go and demonstrate the process for fixing the data in that way. Output everything to another database, and that other database is the end of this notebook. This is kind of a silly thing here, but when you do, I'm sure there's a more approved way of doing this, but when you do a restart and run all and you don't want the content at the bottom of the notebook to run, I just throw some silly line like assert2 equals 3 in here.
You don't want the content after that point to run? Is that why you're doing that?
Yeah, it's some backup
perfect.
investigations that I did. Some really interesting stuff regarding loss functions in TensorFlow, but would be a better fit for the next segment on this talk.
Nice. Yep. There's a lot of traffic in the chat about a follows up session, the TensorFlow version of this, the modeling part.
Yeah.
Cool. Anything else you want to conclude with, Robert?
So I have to admit, I have not been looking at the chat. Is there anything any questions that I've ignored that I should be aware of?
I think you addressed most of them. Very good. Just people looking forward to the next session, and they're really thoughtful and thankful for your time and the detailed analysis you shared with us.
Well, I mean, it's been a learning experience for me. That was the point, not only to learn, but also to develop something to bolster my own data science portfolio. As we learned during the Kaggle session with the 3 course developers, it's important to think about that aspect of career development. And this being a project that I have some personal connection to, and just a transportation nerd in general, so thought it would be a fun set to work with, and a lot of applicability when we get into the time series stuff in the subsequent notebooks. A lot of stuff from Lawrence's course that will be applicable here as well. So,
Robert, there is wonderful work, but I know you mentioned one of the targets down the road. The thing we would try to predict would be how many bikes will be at a station at a certain time, right? Are there additional targets you could, are there any additional targets in terms of predictability here? I'm trying to think if there, could you actually look at like a certain station and predict how long each ride will be, or the duration of rides, things like that, that might, sometimes you can have a multi-targeted type of model that can actually be more accurate for your primary target. I don't know, I was just thinking.
So a multi-targeted model meaning?
So your output, often we're trying to predict one output, right? But you can in a model, you can predict more than one output. So I don't know. It's a brainstorming thing. I was just thinking, are there other things we could predict?
So I will very briefly describe where my head is at right now regarding the modeling. And as you say, there are a lot of different things that one could predict regarding this task. The low-hanging fruit is to estimate the number of bikes that will be removed from a certain dock, or the rate at which bikes will be removed from a dock as a function of time, weather, etc., and to do so using time series techniques. So you're leveraging autoregressive and other information. But at the same time, there are other things that one could predict that are interesting as well, such as the probability of a station becoming empty, becoming full. My thought on this is to treat this as a Poisson regression problem, which I had done with my initial project as well, that I did for my grad school course, and some other things that I showed with that. I guess that's been 5 years now. The idea there being to predict the likelihood that it becomes empty, and then you've got to use some information about the real-time dock status as well. One thing where I wanted to go with answering this question, and it's taken me kind of belabored this, but what could be useful, especially when you think about these large outages, right? Like a station in Columbia Heights, DC, a residential neighborhood where a lot of people are biking downtown to go to work. At 9 a.m., the whole neighborhood, all the stations are empty, right? The people cannot rebalance the stations fast enough. And I know people who live in that neighborhood that, at least pre-pandemic, had essentially given up on the idea of using Bikeshare to commute to downtown at that hour because the docks were all empty. There was just not near enough capacity. So because of that, when we look at our data that are only capturing trips that were actually taken, that is very much understating the demand at such a location. So what I haven't done yet and hope to incorporate in the future versions of this is to use some of this information from the outages here. We have historical information. The station at 15th and P, Logan Circle or something, was full at a certain time, or it was empty at some other time. And knowing when those stations are empty kind of changes the floor on, and maybe you can change the denominator so you calculate a different rate. Does that make sense?
Yeah.
So I think that there are a lot of side pieces of information here that would be very useful in the prediction problem. Right now, what I have done, I've done this EDA and data acquisition pretty extensively. What I had done initially was just kind of build this whole thing through something from start to finish, get a model that works, but then kind of go back and start from the beginning again and really go dive into these guys in detail. So now I'm just kind of getting back into the modeling part. Not that one can EDA and clean data to death, but at some point it's not useful.
I think.
Robert, one thought I had is thinking of network analysis. If rides from one place to another, you might be able to do a network analysis of it and find out that there are actually sub networks in here, and then you do whatever predictions, more simply by just analyzing, that these stations are actually a subnet of the whole thing.
Yeah,
and then characterize different types of subnets.
Yeah, that's an interesting approach. I had thought about that, but not seriously yet.
Mm-hmm.
Definitely interested in talking more about that with you or anyone else who's knows a little bit more about about that.
Python's got some nice network analysis modules or packages.
I will say that my thought on doing something similar was to actually train this almost like a language model and learn embeddings for the stations. And by doing so, you could essentially make a representation learning of each station that will help you reduce the noise from one spot, right? Like maybe your embedding tells you that the station at 18th and Adams Mill is in an entertainment district, right? There might be entertainment district embedding. That's Adams Morgan. There might be a residential district. There might be something that's characteristic of the downtown area. And you could then learn information that you learn from a station in one part of town may be applicable to stations in other parts of town if they have similar embeddings.
Right. And then you could do that temporally too. Like there's the weekend sort of experience and or activity and the weekday activity. The other thing I was thinking, you did some predictions, actually, your explanations of things that went on, and it was looked like an anomaly, and then you were able to figure out why. And it would be interesting on a, I don't know exactly what types of historical questions, but almost like crime or something where you were looking at this information and you were saying, using it to explain or lead you to something that you might not have, it was just anomalous. And then you could kind of use it as a clue to some kind of activity that happened that you weren't aware of. So not like in a prediction, but using it to help explain a historical, something that happened in the past, like why did this happen? And then study, oh, well, it was the cherry blossoms. I mean, the cherry blossoms is an obvious one, but something else.
Yeah, so when I did this project, the first iteration of this years ago, I did somewhat extensive analysis of the missed cases. So I built a regression model with a random forest, actually, and came up with the plot of, this is what we observed for a particular time, this is the number of rides we predicted, and looked at it not at individual stations because there's too much noise for this analysis, but looked at it aggregated across all stations in the system and tried to figure out when is the model really, really missing badly. And in every case, I was able to tie it to some extraneous event, or at least I was able to guess that it was probably related to some event. Like in one case, there was a day with like 2 or 3 times as many commuter rides as expected. And it was a day that the metro system had some ridiculous delays, and there were news stories written about that. The days where the predictions were way too low were often edge cases related to, or I'm sorry, where the predictions were way too high and the actual ridership was very low, were often edge cases related to weather. Where sometimes the database would show, when sometimes my weather data would show that a snowstorm started at 7 a.m. or something, or 8 a.m., whereas in reality it started earlier, or maybe just everybody stayed home because of it.
Like tomorrow.
Right. Now, the other thing that I'm interested in doing a little bit more exploration of is the pandemic and how has that affected things. So in the modeling notebook, I've come up with a couple different train validation test splits. The first of which just ignores the pandemic data entirely and just throws out 2020. and only looks at data from before just to see, okay, how well is the
Mhm.
model doing? But then we also want to see, well, how well does it do if we look at 2020 as well?
Hmm.
That's an interesting one.
This is really, really interesting.
Yeah, I feel like there's so many interesting directions that this data set can lead one that you really just have to pick something and have some kind of discipline, or else you end up doing this all the time.
Awesome.
Thanks, Robert.
Thank you, Kathleen, and thank you everyone for participating and offering your ideas and feedback. It's super helpful to have a community and audience that is engaged.
If anybody wants to give you feedback or reach out to you or maybe contribute to your project, would you be open to that? And is Slack a good way to do that?
Yeah, our Slack channel would be a great way to do that.
Do you have any specific asks from the community or us?
If anyone has experience with some of the ideas that I threw out there at the end, I'm really interested in the embedding approach, trying to figure out how to do that with geographic data. Would be really interested in learning that, and the network analysis approach as well. I think when you get down into predicting individual stations, you'll see that my current models notebook is focused on predicting aggregate number of rides, which is a fine place to start and helps you to see the overall temporal patterns and autoregressive relationships in the dataset. But if the purpose is to predict ridership at individual stations, one needs to come up with a good way of learning from stations beyond just the one, right? The difference between tokenizing a dictionary versus embedding it.
Got it.
Robert, a quick question. Would what you've done here work? There's no reason why it wouldn't work for other cities, right?
Correct.
Okay.
I'm not familiar with the data sets and availability of the data in other cities. I suspect that for the major systems, it's probably at least as good or similar.
Mm-hmm.
I do believe that the second half of 2020, the data is now a standard format, this GBFS. So
Yeah.
that might help with
Embeddings works on strings, regardless of their words or not. They just don't not supposed to have any spaces in them.
Can you repeat that? I didn't understand.
Embeddings works on any symbols. They should be strings without any spaces in them. You can come up with arbitrary words, for example, for each station, or maybe even use number of the station as well, its identification. Embedding looks for connections between these strings. That's it from the data.
Yeah, it's an area I've always been looking to get more experience in, and I thought this was an interesting but very atypical use case for that approach. So I thought it would be interesting to try.
Sure.
Would you mind stop sharing if there's nothing else you want to show us? Awesome, thank you. Cool. Thank you, Robert. That was very detailed.
Yeah.
Very thorough analysis. Let me just share my screen quickly for some notes for the community. So friends, this was a really good session. Thank you again, Robert. Looking forward to part 2.0, and hopefully some of our community members can help you as well in that. That sounds like an interesting challenge. Again, this session is recorded, will be posted hopefully tomorrow in this Kaggle playlist that we have. Thanks for sharing the code as well, Robert. That was really useful. If anybody wants to take a look, it's in the chat. We can also post it in the Slack as well. Speaking of the pandemic, Dimitri shares something with us for different cities. How does the bike share look for 2019 in blue and 2020 in red? And you can see that throughout. This is DC, Boston, New York. So, New York looks like it's picking up. So the pandemic has definitely impacted transportation.
And that's just last spring, right? That doesn't go beyond May of last year.
Yeah, it goes from January to end of May, it looks like. And speaking of ideas like this, I remember when before COVID, there was this nice, interesting meetup transportation tech is where people basically used to develop projects like the one you shared, Robert, with us of your colleague.
Yes, in fact, I'm a member of this group and a good friend of Michael, the organizer, and this is where I first presented this topic at a local meetup.
Yeah, I attended some of them as well, and they were interesting. Many of them were related to metro, the actual metro station. People were trying to figure out where the escalators are broken or where if metro is delayed and things like that. But this was also interesting from the bike share perspective. Cool. Some links that our friends shared with us. The last thing I'll share is this upcoming session. I started working on it next week. I'll be presenting it. This is a more complex game than I thought. Highlight. This is about space bots, navigating in space. This is related to reinforcement learning and game AI. So there's this game that we'll be looking at, and there's a lot of rules in the game. I'm trying some simple strategies, and I'm hoping maybe next week, maybe I'll have some more advanced strategies for us to look at. But if for some reason I'm not able to do that, maybe I'll just pick the 1 or 2 notebooks that are very popular in this competition and just maybe try to understand them better and maybe share them with us as a community. I'll stop sharing here. Again, thank you, Robert. This was super useful. Thank you, everyone, for joining us. Thank you, new members, for joining us. I'll stop the recording here. And I'll see you next week.